Bismillahirrahmanirrahim. This is our 15th lecture of our course Digital Electronics. In this lecture, we will study the T flip-flop. For this, we will start from the AND gate, which is connected with the NOR gate, and we will have the output. We will repeat it again. AND gate connected with the NOR gate and the output. Here we have the T input as like this. We will have the clock. Now these outputs are connected with the NOR gate as input like this, and these outputs are also the input of the AND gate. Now we will start its working. This is our Q bar. This is Q. We will take it as clock, which is always 1, T, Q and Qn plus 1. We are taking the clock equal to 1, T equal to 0 and Q equal to 0. So when our T is 0 and Q is 0, so here we have 1 and 0, it will give us 0. 0 and 0 will give us the output 1. This one will go here as input, and we have T equal to 0, so automatically the AND gate will give us 0. This 0 and 1 will give us output 0. Here we have 0. For 1, 0, when we are imagining the Q as 1, we are taking it as 1. Here we have 1. The other inputs will remain same. 1 and 0 will give us 0. This 0 will go here. 0 and 0 will give us 1. Here we have 1. Now we are taking the clock 1, T1 and Q equal to 0. When clock is 1 and T is also equal to 1, it means we should know the third input. If it is 0, our answer will be 0, and if it's 1, our answer will be 1. So as we are taking the Q equal to 0, it means our Q bar is equal to 1. So our all inputs are 1. Here we get the 1. This Q is 0. 0, 1 and 0 will give us 0. Here we have 0 input, and we have clock 1, T1 and Q equal to 0. So according to the AND gate, we will have 0. 0 and 0 will give us 1 output. We will have 1 here. Now we will take the clock 1, T1 and Q also equal to the 1. So when Q is 1, Q bar will be 0. This 0 will go here as input 1, 1 and 0. It will give us 0. This Q is 1. So this Q is 1. So 1 and 0 will give us 0 output according to the NOR gate. Here we go, we have 0 input, and for this we have clock is 1, our Q is 1 and T is also 1. So it will give us 1. And 1 and 0 will give us output 0. This is our T flip-flop, in which these are our hold-on states, and this is our toggle state. This is how our T flip-flop works.